Hey guys, let's just try this mechanics question. Turned out to be really nice. I was able to take joy in doing this particular one. So we have a thin non-uniform bar, which basically means the center of mass is not at the middle. Let's draw it here. So point A and point B. I know the center of mass is closer to A, so what's going to happen is it's going to be, A is going to be more down, I guess. Okay, and that bar is going to have a weight. I don't really know what that is. I'm going to mark it on a different color. So let's call it W, as we usually do. Don't really care about MG. That's not the point of this question. Now what we notice is it's kind of cool in the fact that there's a light and extensible string attached to each end, and then it's sort of at a smooth peg P. And what that means is if we have this string here and it's doing something like this, there's two things happening. I mean, obviously, it creates a triangle in this kind of plane, right? But we see the force, the tension is going to be the same, acting at each point. And, we're going to call this angle alpha and call this angle beta. Now, what we're going to have here, the last thing I'm going to mark on that's relevant is the distances. So we know this is going to be 3D. And this is going to be 4D. And we'll call that point G, why not? Right. Okay, so that's the first step, just making sure you're drawing that diagram accurately and stuff. Okay, so how can we get this equation? We want an equation linking sort of alpha and beta, and that's it. And if you think about it for a second, remember, there's only two things we can really do for these sort of body questions. It's either take moments or resolve in some direction. Okay, so I noticed that I want something linking alpha and beta, so clearly I want to have these tensions involved somehow. But I don't really want the weight involved. That would complicate things. Is there a way I can have an equation not involving the weight? And you'll see there is, just by taking moments about G. So the first part's not too bad. If we take moments about G, let's sum all the moments to 0. So we have this first moment here, and it's going to be an what's that, anti-clockwise moment. No, it's clockwise, sorry. So that's going to be negative. That's minus t sine alpha times 3d plus t sine beta 4d, and that's just going to be equal to 0. And what we want to do now is just, rearrange and cancel the t and the d, and we get exactly that. So that's fine. Okay. Now, the next thing that we're told that's relevant is we're given the value of cos of beta. And there's a neat trick for deriving the other, like we have cos, but obviously we want sine of beta. We don't really want cos of beta. But if we're told cos of beta is, in this case, was it 4/5? Yeah, it was. So it was 4/5. All we really want to do there is draw this cool picture. That should be a right angle, my bad. But we have beta here, 4, 5, and what do you think this is going to be? We can work it pretty quickly. This is going to be 3, right? And then we can derive that sine of beta is 3/5. If we need tan of beta, we can get that as well, and so on. Now, we can also get alpha pretty easily using that relationship there. We know 3 sine of alpha is 4 sine of beta. So sine of alpha is basically going to be, it's going to be 4 over 3 sine of beta. And we know sine of beta is 3/5. Okay, so that's going to be sine of alpha. It's going to give us 4/5. And you might spot, because we did this already, that if sine of alpha is 4/5, I'll just draw you another triangle to show what that's going to look like. Sine of alpha is 4/5. Again, we want the 4 and the 5, so that's the opposite in the hypotenuse. And then we're going to put our adjacent there, which again turns out to be 3. But notice this. That's just the other angle there. So that's a pretty weird relationship. We see immediately that alpha and beta must sum to give pi over 2. Okay, so, and if they sum to give pi over 2, what this also means is the angle at P is a right angle. So that will speed up this problem immensely. That's pretty interesting to note that if the center of mass is placed in such a position that's the case if cos of beta is a particular value. Okay, you know, and we're given that alpha is acute. You know, of course alpha is acute. I don't see how it could not be acute, really. So we can pretty much, you know, say that's fine. So we know that they sum to 90, which means that the top one's a right angle, and that's going to help us immensely. So what we want to do is, first of all, find in terms of d the length of the string. Well, we see that this entire system is just basically a large right angle triangle now. So let me redraw that. Okay. So that's just going to be a right angle here, and this is going to be 7d. And we know that the length of the string is just going to be, you know, the length of the sum of these two sides, basically. And all I really need to do is mark on an angle there, alpha, and we see that, I guess that's just going to be 7d cos of alpha plus 7d sine of alpha. Okay, and then you can just sort of take that outside and, you know, sum that. So cos of alpha plus sine of alpha, regardless of which one it is, that's 3/5 plus 4/5, giving us 7/5. So that's the length of the string, 49 over 5d. That was pretty quick. Okay, and then what else are we asked to do finally? We want to show that the angle of inclination of the bar to the horizontal is arctan of a 7th. Interesting. So if we mark that on, the angle of inclination of the horizontal, I'll try and mark that on there, theta. I hope that's clear. We can kind of see that though. Okay, well, if that's theta, that's not in a overly helpful position right now. Okay, let me redraw the diagram because it's not going to be clear what I'm about to do now. So start a bit bigger. Probably should have did this at the start. Oh well. So we have A, B. We'll have P up there somewhere. Okay. And marking the angles. That's going to be alpha dash 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 theta. Now what's going to happen is we know that the weight acts downwards there, but much like a you know, standard M2 question where a block will be sliding out of plane, we can actually consider this going this way, perpendicular to the rod. So theta will be in there, and that'll be, you know, what will that be? That'll be omega cos theta. Okay, and we have our tensions acting here. Okay, so now I can actually get an equation with theta in it. You see, all I have to do now is actually resolve parallel and perpendicular to the rod. So the first thing I'm going to write down is, by resolving this way perpendicularly, where am I going to put this equation? Let's put it over here. So we're going to have t sine of alpha plus t sine of beta is W cos of theta. Whoops, W cos of theta. Okay, that's the first one. And then the second one we resolve parallel to the rod. Let me scroll across a bit. And we can see, you know, we can just do that, or basically we get t cos of alpha is exactly equal to omega. I keep saying omega, sorry, it's W sine theta. This guy's gonna be also acting down, t cos beta. Right. Now, okay, notice we want tan theta, basically, so we can find arctan of theta. So how can we get that? Well, we just simply, if we have omega sine theta, sorry, W sine theta. Bad habit of mine. Sorry guys. W, you use W these days anyway. So W sine theta, and then we want to calculate W sine theta over W cos theta, because that's just basically going to be tan theta. We see that, right? So that's going to be T cos of alpha minus cos of beta divided by sine of alpha plus sine of beta. And quickly, well, sorry, there's going to be a T there as well, but what's going to happen is, of course, the T will cancel and the omega 1 W will cancel. We can check that, that, you know, they're both non-zero. It's pretty okay to do. Then we get tan theta, and we notice the top line is going to be, think about that for a second, that's a fifth. Bottom line is 7/5. And hey presto, we have basically arrived at the answer there. Indeed, theta is just arctan of a 7th. So all in all, that question was, it just surprised me that I was able to get that result out that quickly, because I'm very terrible at mechanics. So, you know, that was really not all that much to that. So it just goes to show that, you know, don't dismiss the mechanics section of STEP, particularly step 1, and particularly these questions that are just resolving and taking moments. So this is Chris, and thanks for watching, guys.